Okay, so we have the series from n equals 1 to infinity. We have n cubed divided by 5 to the nth power. So here I'm going to use the ratio test, which says the limit from n goes to infinity. You take the absolute value of the series with n plus 1 divided by the sequence a over n. So right now this, what is given, n cubed divided by 5 to the n, that's my an. And then I'm going to divide my an by an plus 1. So I'm going to add 1 to everywhere that I see an n value. And so I take the limit, and I'm supposed to get, and you get an answer of L. And there's 3 cases. Whenever you take the limit, and if L is less than 1, that means that the series is absolutely convergent. And if L is greater than 1, that means the series is divergent. But if L equals 1, it says that it's inconclusive, so that means that we have to try another test in order to find whether it's convergent, divergent, conditionally convergent, or absolutely convergent. So first step, I just set up everything. So I'm going to add 1 to my series. So I have n plus 1 within parentheses cubed. And in my this is still part of an plus 1. And I have 5 to the nth power plus 1. And here it's like dividing by an, which is my original function, but I am just multiplying that by the reciprocal, which will give me the same value. So I have 5 to the nth power in the numerator and n to the n cubed in the denominator. So I just simplify it, which is the second step. As the limit approaches n to infinity, n plus 1 cubed divided by 5 to the nth power times 5 is the same as this. 5n plus 1 it can be written as 5n times 5. And then this is just my an, multiplying by 5 to the nth power over n cubed. So here I can see that in the numerator I have 5 to the n, and in the denominator of this one, so these two cancel out because they're the same value. So I'm left with n plus 1 in parentheses cubed divided by 5 times n cubed. So here I see that I have an n plus 1 cubed and I have an n to the third, or n cubed. So they're both going to the same power. So in this next step I divided it up. So I'm still taking the limit to infinity. 1/5, it's still the same. It's still equal to this, these are both equal, so it's 1/5 multiplied by n plus 1 divided by n all over to the third. So it's the same as this, because I noticed that they both are raised to the same power, so I put them in parentheses. And here I can see, since these both have the same denominator, I can split them up. So this, everything in the parentheses, as if it's saying n divided by n is 1, so that's where the 1 comes from. And then you add 1 over n, it's still the same. So here I rewrite it as limit n goes to infinity, 1/5 times 1 plus 1 over n to the third power, all over to the third power. So if you plug in n to infinity, we get 1/5 times, in parentheses, 1 plus 1 over infinity, which equals 0. And then you cube that, so it's 1/5 times 1 plus 0, because 1 over n, or 1 over infinity, equals 0. So we're left with 1/5 times 1 cubed, which is still 1, So I have 1/5 is less than 1, and if I look back to the ratio test, and if the answer that I get, my answer 1/5 is L. So since L is less than 1, it means that the series is absolutely convergent. So I know that it's absolutely convergent, but to correctly write this in the correct form, I have to rewrite it as the series from n equals 1 to infinity, n cubed divided by 5 to the nth power is absolutely convergent by the ratio test.